Okay, Bronson, you and your small group started talking, and the first thing you said was to do what? Oh, you had something to say before that.
Combine my turns.
He said, draw the fence. Draw the fence. Okay. But then after that, we need to always start out with distributing. Okay. Do we have distributing? We sure do. Let's distribute that 3 into here. You do it without me. Distribute, please. Yep, distribute. Distribute that. We're looking at the 1 under 1 solution. Page 30. 4, 2, 32.
32.
Distribute the 3 through there. What do we get? 6x plus 27. Nod your head yes or no if you agree. Okay, thank you for nodding your head, Corin. All right. Do we have any like terms that we need to combine? Like I see that I have a variable term here and I have a variable term here, but are they on the same side of the fence? No, they are not. So we do not have like terms to combine. So now we need to move our variable. Okay. Brady, how would you like to do that? Okay, let's go ahead and take the minus 2x and do the inverse operation to move it over. Okay, so by adding 2x, okay, minus 2x plus 2x are going to cancel out. That's what we want. Okay, so on the right side, we're only left with that minus 5. Over here on the left side, 6x plus 2x, 8x. And we have our plus 27. Emily, what do we do next? We're right here. Okay, let's undo our addition by subtracting 27 to the other side. So we still have our 8x. Our 27 minus 27 does cancel out. Okay, help me out. Negative 5 minus 27. Negative 32. I like that because I have 8x on the other side, right? Negative 32 is pretty good to have over there, right? Okay, Ryan, last step. What do we do? How? What do we do with that 8? Okay. So the 8 divided by 8 cancels out, so we're left with x, and we get x equals negative 4. Did that feel any different than what we did yesterday? No, it didn't. Okay. Most of the time, I am going to give you an equation, and you're going to be able to get a numeric answer. Most of the time, but not all the time. Dun, dun, dun. Let's look at this next one. Oh man, there's a lot going on in this one. I think you're going to like this one. Okay. All right. So Tyler, after we draw our fence, the first step is to do what? All right. We see that we have parentheses, so we need to distribute. Okay. So I'm not going to worry about, I'm just going to rewrite the left side since there's no parentheses over there. I'm just going to leave it. I'm just going to rewrite it. And then on the right side, we need to distribute. Okay. Jada, when we distribute, what do we get? 4x plus 12. And then we still have this plus 1. Okay. Ooh, this problem has a lot to it, doesn't it? Okay. All right. After we distribute, we are going to need to combine like terms. So I'm going to go ahead and make my boxes and circles. Okay. Now remember, we are not moving across our fence. We have to stay on the same side of our fence. So I'm going to just zoom in so we're not tempted to. Okay, over here, what can we combine? We have 7x minus 3x. What is that, Bennett? So we have 4x, and then we still have that minus 9, right? Okay. On the right side, well, it looks like I only have one variable term, so I'm going to keep 4x, but then I have two constants. We have 12 plus 1. All right, our next step is to move the variable. And I really like to take the variable that's on the right and move it over to be with the variable on. So if I have a positive 4x over here, how do I get it to the other side? So I'm going to subtract 4x from both sides. Okay, so does 4x minus 4x, do those cancel each other out? They do, and we are left with 13. What happens over here? 4x minus 4x cancel out. And I'm left with Tyler, is negative 9 equal to 13? Is that a real thing? No, negative 9. Like, what is happening? Negative 9 can't equal 13 ever, can it? So this problem has no solution. The point of solving it is to show that there isn't anything that works. The answer is there is none. Like there's no solution. Okay.
So is like that the answer?
So yeah, the answer I want to see is no solution. What? Let's not worry about the symbol. Okay. So we won't worry about the symbol, but what this means is there is nothing I can plug in for X to make it true. It saves you like 3 steps, people. 2 steps. You want to see what that looks like? All right. Trent is on the edge of the seat, wanting to know what infinite solution means. Try your fence. Okay, you told me. Step 1, distribute. Bronson, do we have parentheses?
Yes.
We sure do. So let's go ahead and distribute through our parentheses. Write down what you think that distribution is. Ryan, when we distribute the -2, what do we get on that left side? Why is it a +10, Ryan? Okay, so it's a -2 times a -5. That negative times negative makes a positive. Okay, so now let's go ahead and combine like terms. I'm just gonna go ahead and box and circle everything on both the right and the left. Okay. Cordell, which side am I good to go on? Like I don't have to combine like terms. Left side or the right side? Left side. So I'm just gonna rewrite my left side because I'm good there. Okay. Ariana, on the right side, what do we need to combine? And when we combine those, what do we get? Good. Okay, so once again, since I have variables on both sides, I'm gonna go ahead and pick the one on the right to move it to the left. Well, if I have -6x, we're gonna add 6x to both sides. Oh my goodness, isn't this so exciting? Bennett, what happens to -6 plus 6x? They cancel and we're left with 10. That's what we wanted to have happen. But excitingly, over here on the left side, what is -6x plus 6x? That goes away and we're left with. Okay, now I have a very difficult question for you. How often is 10 equal to 10? All the time, right? How often is 10 equal to 10? All the time this 10 is equal to 10. So we have infinite solutions.
That's what we write down.
Yep. Anything. This means any number we can plug in for x and it works. We have an infinite number solutions. Okay, so let's look at these side by side. The same thing sort of happened, right? When we went to move our variable term over, they both went away. Okay, here's the difference. If you get a true statement like 10 equals 10, 17 equals 17, -1000 equals -1000, if you get a true statement with no variables, we have infinite solutions. If your variables disappear and you have an untrue statement, we have no solution. Okay, so what I'm going to have you do is I'm going to have you try number one. We'll just try number one. You try number one without me. Okay. Draw your fence. You have all the steps in number one. That's why I think it's a good one to try. Totally cool to work with your elbow partner. -3 and you still have that -6. Yep, so now you should combine my terms on that right side, okay? Oh, what is that say? Fine with him? Okay, so now what?
So, what is it?
We're not minusing 3, we can minus 6. With 6 no, this is a minus 3. We need to set that minus 1. So it's 5x minus 3. Okay. I'll tell you what you can write here as a shortcut. Okay, so the first step would be to distribute. Did you do that? Kinley, did you distribute first? Yeah. Does it look like that? Okay, great. Second step is to combine like terms. So it looks like the right side is the only side we have to worry about that with, correct? Okay, Corin, when we combine like terms on the right side, what do we get? Yep. This is exciting. Yeah. Right? Arisan, what did you do next? Okay, and you did that by subtracting 5x. So these go away and I'm left with minus 3. And these go away and I'm left with minus 3. Tyler, what does this mean? Okay, infinite solutions. Now, some of you are struggling with writing the word infinite. Do you know the symbol for infinity? Yeah. What just happened? Why did you do that? Okay, we'll address that in a little bit. So if you don't want to write the word infinite, you know what, I need to unprop my door because they might not.
Oh my gosh, that'd be
No, they're behind my door. I'm so sorry. That's my fault. There. So the infinity symbol is like a sideways 8.
What? So you do the 8 and then you make the edge.
Okay, so we're gonna do a class vote. We can go through one more problem together, or you can start your homework. Who would like to go through one more problem together? Okay, as a class, you are voting to start your homework, which means every single last one of you is working on homework. Okay, turn your pages to 34, and you have 1 through 8.
Can I please go to the restroom? This woman.
Last one, Corin.
Shy Avery.
What? I'm gonna go aggressive.
Can you?